Welcome back to Healthy Design. I thought today we would finally talk about the cell danger response. I'm not sure if this will end up being kind of multiple parts. Today, definitely just want to at least get an overview in, but probably will want to go into things a little bit more in depth at a later point. So, not sure if I'll kind of keep following up with this or maybe later on down the road come back to it. But if I can too, what I want to try to do is maybe include one clip from Dr. Robert Naviaux. He's got a couple talks, lectures that he's done that are posted on YouTube. And there's one clip I'm hoping I can kind of snip in here and let you see it. Because yeah, if not, I can definitely link to some of his talks. That way you can learn about things too. So just finished doing my morning walk. It was a little cold outside, so that's why I'm kind of all bundled up with the hat and the jacket. But anyway, just in case you're wondering why he's wearing that inside. But so the cell danger response is from Dr. Robert Naviaux. He has a lab where they're looking into mitochondria, so like different mitochondrial diseases. And what a lot of people probably would be surprised to know is that there's been a whole lot of research, like a ton, that's been done on pathology and pathophysiology. So we know a lot about kind of how we get sick, what makes us sick, different things like that. But very, very little research has been done as to how we actually heal. And so that's what he's kind of looking into. And so he's coined a new term, salugenesis. So like pathogenesis is how disease or pathology starts, and salugenesis is how health or healing is started and created. Um, so we know that there are different pathogens, things that can make us sick, and so he also believes that there are different salugens that can make us healthy. And so there's, probably things in the rainforest, probably, things in coral reefs, different things like that that might play a big part in actually helping us to heal and starting that process. Um, the way things have kind of worked in medicine for, well, since it was created, is that we've gotten really good now with conventional medicine of dealing with acute injuries, like things that could be very life-threatening immediately, and we have things we can do to help that out. But then people would have to kind of go through this, what he coined as the black box of healing. So it's kind of like, we would do these steps, but we would just kind of take for granted that people would do that healing part, not knowing how it happens or what does it, and then they'd be fine coming out on the other side. So we can see that a lot of times, and most of the time that does work pretty well. But it doesn't always. Sometimes people have an injury, they have a treatment, they heal partially, but not completely. So that's what he's trying to figure out. And so that's really part of what the cell danger response is. The cells respond to this danger signal, danger input, based off of an injury or some type of insult to us. And then they go through this stage, CDR1, CDR2, CDR3, and then we're back to kind of our normal state again. So it's kind of like we have this state of healing, something happens, we get injured, and then we do CDR1, CDR2, CDR3, back to normal, and then that process just kind of keeps repeating throughout our life, because there's going to be different things we're exposed to that are going to create different injuries or insults to us, and our cells have to heal. And so I guess the biggest thing is, he mentioned some different things in that talk with conventional medicine, like, using medicine, it doesn't heal people. It's not to say that medicine is bad and no one should ever take medicine by any means. It's not saying that. Again, this is not medical advice. This is informational purposes only. It's just that, if you're, so like for diabetes, if you're taking metformin or insulin, it doesn't cure the diabetes. Now, it does kind of help to prevent further injury, further insults, different things like that, so things don't keep getting worse, but it doesn't cure the issue. Allergy medication is another one. It doesn't cure the allergies, but it can make you feel a whole lot better, function a whole lot better. So there are benefits to the medicines, there's no doubt. But he wants us to kind of look into things that might actually lead to healing, where we can cure diabetes, cure allergies, and not have those issues anymore. So again, that's not to say that like conventional medicine's bad or wrong or anything like that. It's just, it's not complete. That's not to say that functional medicine or alternative medicines are complete either. You know, they have their strengths and weaknesses. Conventional medicine has its strengths and weaknesses, and I feel like they're kind of complementary to each other. You know, a lot of times with the conventional medicine side, you don't get more of the lifestyle factors that can play a big role in health, and I think they play a big role in us being able to go through that, you know, cell danger response to those different stages of healing as well. So a lot of it, he's kind of mapped it out where there's specific things that kind of need to happen in those stages, and there's checkpoints to kind of go from CDR1 to CDR2, CDR2 to CDR3, and then CDR3 we're just back to normal. And so, you know, sometimes things can get clogged up in those checkpoints you can't get through, and that's why people get stuck and have different issues. And so one of the main things with his research is that mitochondria are involved in all of this. Most people think of the mitochondria as kind of what you learned back in school, that, you know, they're the powerhouse of the cell. They produce energy, which is true, but that's not all that they do. They play a part in the immune system of recognizing when there's a danger to the cell, and so then they will respond. And so one of the things he mentioned too, that in a healthy cell, there's more than just one mitochondria in a cell. And so in a healthy cell, the mitochondria function more together, like a, you know, coordinated unit. But as they get injured, or as the cell gets injured or something comes on, they fragment and become more independent. And so part of what happens is that the mitochondria will sense that there's a danger, and they'll kind of start to wall themselves off to protect, you know, the other mitochondria, or that mitochondria might have walled itself off to protect it from something going on over here. And you'll see that with cells too, as the cell, it can kind of, it starts to wall itself off to be protected. And then the ATP, or some of the different purines, the P, just take that as a purine, those purines actually signal, when it's extracellular, it signals to the other cell that there's a danger. And that extracellular ATP can actually be kind of some of the fuel that's used to continue those stages in the CDR to get to healing. So basically what we see is that our body's pretty intelligent, and it has a way of doing things. He even mentioned in it, which is something I've said too, is a lot of times we just need to get out of the way, kind of give our body what it needs and then get out of the way, because I think it's a lot smarter than we are, and it knows what to do, but a lot of times we're keeping it from doing what it should, instead of giving it that freedom and giving it what it needs to do it. And so, you know, he seems to kind of agree with that in some ways too, that, you know, there's things we can do to help out, but, you know. So, and what will happen too is the mitochondria will change their state. So they'll become different forms, because if we're trying to deal with like an infection, for example, then they need to do something different. And so this is, again, we see a lot of sickness behavior, it's called. You know, when you get a cold, get the flu, you don't have any energy, you don't want to move, you're sitting still. And that's part of it, because we're going through this process. Our body's trying to fight some things off. So it's, you know, the mitochondria is worried about doing that, rather than just giving us the energy so we can do all the things we normally do during the day. You know, basically that energy is being used to fight things off. And then as things are fought off, we start to feel better, and then we're back to normal. And so in the CDR1, the mitochondria become what's called M1 mitochondria, and they are actually pro-inflammatory. So they are going to produce inflammation, they're going to produce reactive oxygen species, and this is what they are designed to do. So it's not that there's an issue with them and they're doing something wrong, they're doing exactly what they need to do. That's helping the immune system to deal with whatever it needs to deal with. And then we go to CDR2, the mitochondria actually change to an undifferentiated state, or dedifferentiated. They're M0. So it's not a like 0, 1, 2 is how the process goes. It's actually, we start with M2, then we go to M1, then we're M0, then we're M2, and they have to go. We'll get to that in a second. So those undifferentiated mitochondria come from stem cells. And so in that stage, we need more proliferation, because in CDR1, if there's enough damage to the cell, it's going to die. Apoptosis, phagocytosis, different things will occur to kind of take care of those damaged cells. And so then we need to replace those damaged cells. And so we need these undifferentiated mitochondria that come in and take whatever, be whatever. And so that's a good thing. So we want that proliferation there. We want new cells formed. And then CDR2, again, the mitochondria change to the M2 state, which is anti-inflammatory. And in this case, it's kind of about more becoming mature. And so the cells, those new cells, new mitochondria, they have to learn how to function and act, and the other cells around them help them function and act. So, whatever cell type it is, it's going to use those neighboring cells to kind of learn how it's supposed to act, how it's supposed to respond to things. And then that continues, we're healthy again. We got those anti-inflammatory mitochondria and everything's good. So that's the quick overlap or quick overview of what the cell danger response is. And so we can see that if we get stuck in certain phases of that it's going to be, well, it can lead to certain disease processes. And so with the CDR1, again, kind of a pro-inflammatory state, then systemic inflammation, things that have to do with that are going to be common. That's where if we get stuck in that, we're going to have diseases that correspond with that. And CDR2, we got a proliferative stage. And so he mentioned diabetes being part of this. This is also where cancer comes in. And just a quick tangent, I guess, or a quick rabbit trail on this. One of the types of metabolism we see in CDR2 is this Warburg metabolism, and that's actually what we see with cancer cells. That's how, even without oxygen, they can still produce so many cells and rapidly respond. So it makes sense that in this proliferative stage, if we can't get out of it, it could lead to certain issues along those lines. So there's different things you can read on that too. Dr. Thomas Seyfried, he's done different podcasts. He's written a book. I think it's Cancer is a Metabolic Disease, if I remember right. I think that's the title. Tripping Over the Truth is another book that talks about cancer a little bit and just how, just some of the different things about it. So I don't want to get too far into cancer, but it's amazing kind of how all that works. So CDR2, we can see some of those types of things. In CDR3, we can see different neurodegenerative disorders. This is where we also see autism and Parkinson's, and then we also see chronic fatigue. And so it's interesting to see, and he's in some of his papers, he's got it listed out, all the different diseases that you can see under those different stages. And once you kind of think about it, a lot of it makes sense while we're seeing that. And so one of the other big keys that I really like from this talk, and I am just kind of paraphrasing his talk, so I'll link to it along with if I can get that clip. But what he says is, chronic disease is the lack of healing. And it's kind of funny and seems like you're being, just a smart aleck, but that is what it is. We're just not able to complete that process and we get stuck somewhere, and then we have chronic disease. Normally with an acute issue, once you take away what caused it, the body goes through that kind of black box and we heal coming out the other side. But when we have something chronic, we've gone through that black box, but we didn't come out completely on the other side. We got stuck somewhere in there. And so I think that's a good way to kind of think about things. And that's why, when we are trying to heal, well, let's back up a little bit. So here's a common analogy, metaphor people will try to use. A lot of functional medicine people try to use it to kind of show what, trying to get to the root cause of things. So let's say someone has a pebble in their shoe and they keep walking and so their foot hurts. So you can treat it a lot of different ways. You got pain, so you could take a pain medication. There's going to be inflammation, so you can take Tylenol or something just to deal with inflammation. But that doesn't deal with the true issue there. So you can take those things, but you're not healing, you're not curing anything because you still have the pebble in your shoe. And so in that case, we take the pebble out of the shoe. Eventually everything should heal if everything goes as normal. And so whenever we're trying to heal from something, we do want to take out whatever triggered it in the first place, but not all chronic disease still has that trigger present. And so I think that's probably more what we'll talk about another time, is some of the different kind of categories of chronic disease, I guess you could say. It's something he mentioned in his talk too. And just that, sometimes that trigger is gone, but the lingering effects are still there. And then also there is this kind of memory with the immune system and with the cells. And so it gets pretty interesting. But again, part of what I want to show in that clip, if I can get it off of YouTube and not get flagged, or and add it to mine, is that it was actually with a plant, and they had to add some things to it so you could see this on the screen. But you see where there was a bite taken out of a leaf, and then the whole plant lights up because the cells are communicating with each other. And so this is what happens in plants. It's what happens in animals. It happens in us. And so I just think it's really interesting to see that. And now they sped things up, so it doesn't happen just instantaneously like that. But again, I think it helps to get the point across that there is this communication that's going on that we're not aware of all the time. So anyway, that's a fairly quick overview of cell danger response. Hopefully it makes sense and it's not too confusing. We will go over things a little bit more in depth. Not sure if it'll be the next episode or if it'll be further down the line, but we'll get it at some point, because I think it can just help make sense of a lot of things. And so, I think having this knowledge in the background, whether you're in healthcare, whether that's physical therapy kind of healthcare or medicine, or whether it's more mental health as well, I think we need this back in the background running whenever we're dealing with any issue, and kind of trying to figure out how it all plays together and what might help our clients, patients to feel better and to complete that healing cycle and get back to their best self. So anyway, that's it for today. Hope you guys have a great one. See you next time. Bye.